Welcome to the next episode of the X-Celerate webinar series. In this episode, we take a look at AVEVA Plant SCADA. My name is Diresh Chotu. Today, we will be looking at the features and benefits of Plant SCADA. We will delve into some technical demos. We take a look at licensing models available for Plant SCADA, as well as the latest features in the new release of Plant SCADA 2023 R2. We end this session by looking at the key info summary. Let's get into it. What is Plant SCADA? Plant SCADA is AVEVA's leading high-performance supervisory control and data acquisition SCADA software solution that is used to manage and monitor processes in manufacturing, primary production, utilities delivery, and facilities management. Plant SCADA has been designed with flexibility in mind. Therefore, a system may be configured to suit your industrial application and project requirements. Plant SCADA suits both small and large applications and can be configured to keep pace with the plant and information requirements as they change and expand. Plant SCADA is easy to learn and use. Features such as templates and wizards help reduce the time and effort required to configure Plant SCADA system. Plant SCADA is a supervisory control and data acquisition SCADA solution used to manage and monitor processes in manufacturing, primary production, utilities delivery, and facilities management. Plant SCADA has been designed to be configured to suit the need of industrial application and project requirements. Plant SCADA is suited to both small and large applications and can be configured to keep pace as requirements change. Plant SCADA is easy to learn and use. Features such as templates, genies, and wizards help to reduce the effort and time required to configure and maintain the system.
On this slide and the next few slides, we look at some of the benefits of Plant SCADA.
Meeting your operational needs. Provide operators with clear information about the process with the context-aware workspace. Alarm and trend information with operator comments in a single view to quickly identify when and where an incident occurred. Advanced alarming and trending with millisecond resolution. Access plant and process data from outside the plant via dedicated browser clients, smart devices, or even via SMS to your mobile phone. Meeting your engineering needs. The ability to engineer and modify your entire process control system from a single location. Flexible and targeted system engineering tools to support your efforts to be more efficient. Reusable and extensive object libraries with control configuration. Offline simulation to reduce testing and commissioning time. Data management and reporting needs. By providing connectors to process enterprise historians, allowing reports to be generated. By providing mobility clients through Plant SCADA Access Anywhere. Using industry standards, alarms can be managed effectively through an alarm management. Your mobility needs. Plant SCADA Access Anywhere delivers full SCADA functionality to your smart device as if you were on the plant floor. Address real-time issues in the plant remotely, troubleshoot equipment, or access key process information whether you're in the office, at home, or on the road. The client end runs on the Access Anywhere server and displays Plant SCADA graphics in the web browser. The Plant SCADA Access Anywhere server records every mouse click and keystroke sent from the remote user. The AVEVA portfolio consists of 3 pillars, namely design and build, operate, and optimize. Plant SCADA forms part of the operate pillar for operations and control. On this slide, we explore the edge to enterprise solution offerings. Edge to enterprise is divided into 3 main areas. The first area being asset location, which is where AVEVA Plant SCADA resides, alongside AVEVA Edge and AVEVA InTouch HMI. This is the plant level of the operations where data is retrieved from field devices. The second area is the control room, or UOC. This is the area where system platform and its components reside. The third area is across enterprise, which is where the cloud-based applications such as AVEVA Integration Studio and AVEVA Insight reside, with AVEVA Connect as the gateway. The Edge to Enterprise solution offering enables connectivity in many different ways. In this slide and the next few slides, we take a look at the Plant SCADA main applications. Plant SCADA Studio allows you to create and set up a logical representation of your plant environment. The configured environment can then be used to supervise and control the plant at runtime. The Plant SCADA Studio is divided into several activities such as projects, topology, system model, and deployment, allowing you to access different SCADA functions through a single interface. The graphics builder is the tool you use to create and configure graphics pages. You can add content to a page that makes it reflect the area or processes it will be used to monitor. The SciCode editor is used to write, edit, and debug your SciCode code. The SciCode editor behaves similarly to other code editing tools such as Microsoft Dev Studio and contains many advanced editing features. The Computer Setup Editor is a utility designed to help you manage your scitech.ini files. It combines a graphical user interface with an extensive help system. The interface provides a convenient way to view, search, and modify parameters within a scitech.ini configuration file. The help system navigates the user through the parameter reference documentation, displaying the topic relevant to the current parameter. In this slide, we introduce the main navigation for Plant SCADA Studio, which is the activity bar. The activity bar is the vertical bar on the left of Plant SCADA Studio. By clicking on the burger menu button, a slide-out pane appears, providing descriptions for the various activities. These activities are described in the next slide. On this slide, we look at the different Plant SCADA activities. The projects activity allows you to create and manage your projects. Project activity also lists all your projects. You can rename, backup, restore, run, compile, or delete a project in this activity. The topology activity allows you to configure computers, clusters, I/O devices, or run the profile wizard. The system model activity allows you to configure and view equipment, variable tags, alarms, trend tags, SPC tags, and accumulators. The visualization activity allows you to configure keyboard commands and edit menu configuration properties and report formats. The security activity allows you to configure and view security information such as user roles and user and group permissions. The standards activity allows you to configure and view reusable assets across your projects, including parameters, labels, and fonts. The setup activity allows you to configure alarm categories, devices, groups, languages, events, reports, and keyboard keys. The deployment activity allows you to manage and distribute versions of the runtime projects to computers in your network. The license activity allows you to launch the floating license manager or update a Sentinel protection key. The activity menu displays at the top of the window in an activity. It includes tabs for each function associated with the selected activity. The name of the currently selected activity is displayed on the left. Next to it, back and forward buttons are provided to navigate directly to activities and views that have recently been displayed. The selected activity menu tab is displayed with an underline. The command bar is located below the activity menu. It displays commands that represent one or more actions that can be performed within the selected activity. Each option or button on the command bar performs a specific task. Command bar options have one or more sub-options accessed via drop-down control. For example, the Add option in the Home tab consists of following tasks commands as shown below. Compile messages area. You might encounter error messages when you compile a Plant SCADA project. Compile errors can be viewed in the Compile messages area in Plant SCADA Studio. By double-clicking on any of the columns in the Compile messages area, it will navigate to the error that you are currently seeing. The grid editor is an interface that displays information in a tabular format in numbered rows. Use the grid editor to add, edit, or delete values individually or in bulk. You can change the way data is displayed by changing the column on which the information is sorted or by changing the sort order. You can also change the display by adding columns to or removing columns from the grid. To revert to the default display of the grid editor, select Reset to Default Columns. In this slide, we look at the architecture and topology in Plant SCADA. A Plant SCADA monitoring and control system may be configured to suit any industrial application. Plant SCADA has been designed with flexibility in mind. Therefore, a system may be designed to suit the exact project requirements. Plant SCADA suits both small and large applications. Because it is flexible, Plant SCADA will keep pace with the plant and information requirements as they change and expand. Although the modern computer systems have a very high degree of reliability, it is necessary for modern production facilities to minimize interruptions of operation. Full multi-server redundancy in Plant SCADA may be implemented without changing the project configuration. The computer view in the topology activity represents the computers included in your Plant SCADA system and the server processes that run on them. Each server process needs to be assigned to a computer and then run on that computer at runtime. Clustering allows you to group different sets of the runtime components within a single project, allowing multiple independent systems to be monitored and controlled. Many Plant SCADA items require a cluster to be specified in order for them to work correctly. There are countless variations in how a clustered system can be configured. An appropriate configuration will depend on the requirements for the solution to be deployed and the environment in which it is being deployed. Server processes. After you have configured computers, network addresses, and clusters, you can add server processes and assign them to clusters and computers. Primary and standby alarms, reports, trends, and I/O server processes can be added in Plant SCADA Studio's topology activity. Redundancy in Plant SCADA can be defined at many different levels. When building redundancy for your system, you need to consider the degree of protection necessary to meet your requirements. A client is a computer that accesses shared network resources provided by another computer called a server. Plant SCADA's client-server-based architecture is designed to distribute the processing tasks and optimize performance. Plant SCADA redundancy. Here we take a look at network redundancy. You can use the dual NIC or network interface cards capabilities of each client or server, enabling you to specify a complete and unique network connection from a client to a server. Each of the system components in the cluster are connected to two networks, LAN 1 and LAN 2. This is achieved by using the dual endpoints for each server. This provides LAN redundancy as follows. If LAN 1 is suddenly inoperative, each component in the cluster can easily maintain connection by using LAN 2. In turn, if LAN 2 becomes inoperative, LAN 1 remains in operation. For this type of redundancy to work, each system component needs to have two NICs to support two parallel LANs. On every computer, each NIC needs to use a separate IP or network subnet. I/O server redundancy. Systems with a single I/O server can be interrupted by the inoperability of a single device or process. If the primary server isn't operating normally, control and monitoring of the system is lost. By introducing a second I/O server and dedicating it to communicating with the same I/O devices, the ability of a single device to influence the system as a whole is minimized. You now have a primary and standby I/O server in your system, when the standby I/O server will assume operations in case the primary I/O server becomes inoperative. I/O devices. Plant SCADA can communicate with any control or monitoring I/O device that has a communication port or data exchange interface, including PLCs, programmable logic controllers, loop controllers, barcode readers, scientific analyzers, remote terminal units, and distributed control systems. In a Plant SCADA system, I/O device communications typically consists of four key parts. The Plant SCADA I/O server. The Plant SCADA computer that directly connects to an I/O device is an I/O server. I/O servers are responsible for servicing the read, write, and subscription requests from clients. A project can have many I/O servers, with each cluster able to include multiple I/O servers. An I/O server keeps up-to-date information on its connected I/O devices by regularly retrieving data from and storing it in a cache. Whenever a Plant SCADA client requires data from an I/O device, it will use the information stored in the I/O server cache. Clients will not retrieve data directly from an I/O device. I/O configuration overview. Plant SCADA supports over 140 device drivers, enabling communication with a vast array of production devices across several communication types. These include generic drivers that support industry standard protocols such as OPC and Modbus. Much of the functionality of the protocols and transports can be modified using the driver options and parameters. A good place to start when setting up communications is with the device communications wizard, a tool that automatically configures a default setup according to your specified requirements. Once you understand how the setup works, you can manually configure arrangements that are more complex. In this example video, I will demonstrate how to create an I/O device in Plant SCADA. From Plant SCADA Studio, we navigate to the activity bar on the left and click on the topology activity. In the topology activity, we select I/O devices from the activity menu. The command bar then displays the options for the I/O device activity menu item. There are various methods available to create an I/O device. The first method we look at is by clicking New Device on the command bar. We are then presented with the device communications wizard, which will guide us through the process step by step. Firstly, we select the project that we want to create the device in. We can click the drop-down and select the applicable project. On the next page, we have the option of creating a new I/O server, or we can select an existing I/O server from the list below. On the third page, we provide a unique name for the new I/O device. On the fourth page, we choose the device either external, such as a physical PLC or RTU device, a persistent memory device, or a legacy disk I/O device. On the fifth page, we select a device from a wide range of manufacturers. Ensure the model and communications method is correct for your application. For this example, we are using the Schneider Electric Quantum Series PLC, and the communications method we are using is Modbus TCP Ethernet. On the sixth page, we enter the device address or IP address if you have selected a TCP IP driver. In our case, we are using the Schneider Electric Quantum Series with Modbus TCP Ethernet protocol. On the seventh page, you have the option to link the I/O device to an external tag database. For this example, we are going to leave the default options and click Next. Lastly, you are presented with an overview of your selections. If you are satisfied with your configuration, you can click Finish. On the I/O devices activity menu, we can now see the new I/O device has been created on the grid editor. When working with I/O devices, please ensure that you reference the driver reference help. This contains all the help information regarding all the different device manufacturers. It's highly recommended that you reference the help file. The system model and equipment. In Plant SCADA, the term equipment is used to describe an object-oriented architecture within a project that can be used to reference the machinery or processes being monitored. Equipment definitions create logical groupings that allow you to organize your project using a hierarchical design. Each definition brings together the base SCADA properties into a single entity that can be easily replicated within your project. For example, if a pump is represented in your project as a piece of equipment, it will bring together the tags, events, alarms, permissions, communications, scheduling, and scripting associated with the pump. You can associate the pump with a particular geographical area or include it as part of a functional process. Equipment hierarchy The term equipment hierarchy refers to the object model that is created by the equipment definitions in a project. When you define an equipment instance, its location in the hierarchy is reflected in the equipment name with a period used to indicate levels in the hierarchy. Equipment types. In a plant SCADA project, the term equipment type refers to a template that you can use to associate multiple instances of a particular piece of equipment in your project. For example, if you have a motor that is deployed in numerous locations across a production facility, you could create an equipment type to act as a template for the motor. This will bring together many of the configuration settings required to add each instance of the motor to your project, such as the associated variable tags, operational states, cluster associations, and so on. To then add one of the motors to your project, you simply create a new instance of the equipment type. This offers the following benefits. Minimal configuration is required to deploy multiple equipment instances. Configuration is consistent across multiple equipment instances. Equipment instances are automatically integrated into the project's equipment hierarchy. An equipment type maintains an association with each equipment instance that is created from it, allowing any changes to be easily applied across the entire project.
In this example, I will demonstrate the features of the equipment editor. To launch the equipment editor, we navigate to the system model activity. With the equipment menu item on the activity menu already pre-selected, select equipment editor from the command bar. We are then presented with the equipment editor dialog box. On the equipment editor on the left-hand side, we have two tabs. These are equipment and equipment types. With equipment types tab selected, on the right-hand side, observe the list of equipment types provided with this project version. These are meter, drive, valve, etc. For this example, we start by creating a transmitter from the equipment type tab. We do this by right-clicking the example project or the selected project that you're working with and click Add Type. Then you're going to type in the name transmitter. You have the option to choose the project which you want to create the transmitter in. I'm going to leave the default and click OK. We now see on the right-hand side, the transmitter equipment type has been created. Next here, we are going to add an item. Okay, I'm going to add a PV parameter. Observe the variable tag fields that appear on the bottom of the transmitter form. Standard parameters populate some of these fields already. These are the name of the I/O device and the cluster name. The values added in these fields will be used as a template for creating new transmitters in the project. Since the name of the variable tag After creating the transmitter equipment type, we are now going to create two pieces of equipment from the transmitter equipment type we have created in the previous example. We start by selecting the equipment tab on the left-hand menu. We then navigate down the equipment hierarchy and expand mixing. We are going to create a level and temperature transmitter under mixing. To do this, we right-click on mixing and we select new equipment. On the Add New Equipment dialog box, we type a name for the new instance of the equipment. Under the Type dropdown, we select the transmitter equipment type that we have created in the previous example. For the project, we can leave the default for this example and click OK. You can now observe that the LT100 has been created on the right-hand side under mixing. We now need to configure the LT100. Okay, after I've updated the equipment fields, I'm going to update the engineering parameters on the engineering group that we've created. Okay, by scrolling all the way down, I'm going to add in the set point of 20 for the low, 80 for high, and the units we are using are liters. Okay, so I've created the LT100. I'm now going to save. Okay, once you've done creating your equipment instance, you then need to use the Update Equipment option. Okay, so you click File, Update Equipment. And what this does is it synchronizes the equipment editor with Plant SCADA Studio. Okay, so once the equipment update is complete, we can close the equipment editor. And by navigating to the Variables Activity menu in Plant SCADA Studio, if I scroll all the way down, I'll notice that we see the LT100 has been created for us. Okay, so working with the equipment editor, when you create an instance of an equipment type, it actually does create the variables for you in Plant SCADA Studio. Okay, you will also notice that the hierarchy is represented in Plant SCADA Studio. You can see we have company.topmilk.mixing.lt100. So that represents the different levels in hierarchy on the equipment editor. If we go back to the equipment editor, we expand company, top milk, mixing, and LT100. So that represents the different levels. Okay, this makes working with equipment very easy in Plant SCADA. Any changes to the transmitter equipment type in the equipment editor will update all instances, such as the LT100 and TT100 that we've just created.
Situational awareness in Plant SCADA. Situational awareness is about knowing what is going on in the environment. On the most basic level, situational awareness is about knowing what is going on in the environment and its implications for the present and future. While this might sound straightforward, in a stable and simple situation, it can become a real challenge in a fast-paced and complex environment. This makes situational awareness a concept that is especially relevant for situations characterized by a high level of volatility, uncertainty, complexity, and ambiguity. Situational awareness has been recognized as a critical, yet often elusive foundation for successful decision-making across a broad range of situations, which many involve the protection of human life and property, including law enforcement, aviation, traffic control, ship navigation, healthcare, emergency response, military command, and control operations. Lacking or inadequate situation awareness has been identified as one of the primary factors in accidents attributed to human error. Situational awareness projects. A situational awareness project is designed to support abnormal situation management for operators. It can be used to create a Plant SCADA project that provides accurate information to an operator in a way that can be perceived and acted upon quickly without overwhelming their cognitive abilities. The objective is achieved through a consistent look and feel for graphical content, the use of standardized color settings optimized for perceiving process data and alarms, the use of objects that conform to an optimized display hierarchy, easy access to information related to the selected context, the inclusion of navigation aids, and operator dashboard. Key components of a situation awareness project. A project created from a situation awareness starter project uses the workspace architecture to enable the runtime environment to respond to contextual changes. Screen profiles. A screen profile defines the arrangement of screens used by Plant SCADA display client with multiple monitors. You can create a screen profile in the setup activity in Plant SCADA Studio. You can then apply a screen profile to a display client using the screen setup page of the computer setup wizard. A workspace. The workspace is the engine that manages the contextual content changes within each screen. It enables contextual navigation and optionally provides a tailored situation awareness aligned operator experience. A startup context is set for each workspace by linking each screen to a level 1 entry in a project menu named Navigation. This provides a starting point for any contextual navigation that occurs within the workspace. Startup context is set for each screen via the screen setup page of the computer setup wizard. In this example, I'm going to demonstrate creating a new screen profile. From the activity bar on the left, we select the setup activity. On the activity menu on the top, we select screen profiles.
You will notice that 3 screen profiles have already been created with the example SA project. I'm going to add a 4th one. Okay, so we can create a new screen profile by either using the grid editor, or we can use the properties grid on the right hand side. We start by entering a new name for the screen profile. I'm going to add a description. And then I'm going to add a second monitor. Okay, so from the properties grid, we also have extra options such as orientation and resolution. So I can actually choose the orientation of my monitors. I can click portrait and swing that monitor around. I have the option of changing both. I'm going to leave them as landscape. Okay, for resolution, we have multiple options. I'm going to leave the HD 1920 by 1080. Okay, so a new screen profile always consists of one monitor by default. I'm now going to save. Okay, so I've saved the screen profile. Next, I'm going to launch the computer setup editor from the project's activity, and I'm going to configure the example SA project to use the new screen profile that I've just created. We do this by navigating to the project's activity, and from the command bar on the top, I'm going to launch the setup wizard. Remember, in order to run the computer setup editor, we need to ensure the project is compiled. If it's not compiled, launching the computer setup editor will compile the project automatically. Okay, I'm going to select custom setup and page through until we get to screen profiles. Okay, if I click the drop down, we can see the 4 options that were created on the grid editor. We've got the 1 monitor 4K, 1 monitor HD, 2 monitors HD, and we've got the demo screen profile that I've selected. Okay, I can configure the context and I can go and select the startup pages for each of those monitors. In this case, I'm just going to choose the same screen for both of them. Okay, you can click next until you get to finish, and that concludes creating a screen profile.
Workspace concepts, master page. A master page provides the layout for the content that is managed by a workspace. It differs from other graphics pages as it is made up of a set of panes that each host individual pages at runtime. The size of a master page needs to match the resolution of the screen on which it will display. The master pages that are provided with Plant SCADA come in 2 resolutions, namely HD 1080 and UHD 4K. Panes are sections within a master page that form a framework for the content that appears at runtime. Each pane hosts a page that can be dynamically updated. The properties associated with the pane allow you to specify how it behaves when the context of a client changes, the type of content it can display, and how a page fills the space within the pane. If your project is based on Plant SCADA's situation awareness starter project, a default layout of panes is available via the included master pages. Workspace concepts, default layout. When you create a project using the situation awareness starter project, the default workspace will include the following arrangement of panes. The header bar includes a set of commands that an operator may require regular access to during runtime. The page content area displays the pages you create to represent your plant or production facility. An operator dashboard also appears along the bottom of the interface. It includes the active alarm zone, which is available on the 4K resolution only, navigation zone, faceplate zone, information zone. Creating content pages. Content pages display the user-created content that represents a production process or overview. With the situation awareness project, it is recommended that you create content pages that are sized according to the pane in which they will appear. In a default starter project, this is the page content area.
Here is an example video showing you how to create a page using a page content template. From Plant SCADA Studio, we navigate to the graphics builder on the activity bar. The graphics builder remains open in the background at all times as long as Plant SCADA Studio is opened. In the graphics builder, we can either click File New, or we can click the plus button to create a new page. We're then going to select New Page from the dialog box. We are then presented with the Use Template dialog box. So here we have the option to select from multiple templates, such as master, navigation, header bar, and page content. We will use the page content template. You need to ensure that the correct project styles and resolution is selected. In this case, we're using the situational awareness style, and the resolution is HD 1080. I'm then going to click OK. The new blank page will now open in Graphics Builder. We can right-click and check the page properties to confirm that it is using the correct page template. So we have the page content, and the resolution is HD 1080. As an example, we can also navigate to the visualization activity and pages activity menu and confirm that the mixing plant page has been created using a page content template on the properties grid. So we look at the mixing plant page that we have already created. On the properties grid, we can confirm under templates, we see that it's using the page content template. In Plant SCADA runtime, when clicking on the mixing plant page or home page, we see that the page opens in the page content area. So currently we clicked on receiving. We can confirm on the top it is receiving that's displayed. By clicking the home button, this will display the mixing plant page. And we can confirm the mixer plant page is displayed within the page content area.
Page templates. Page templates are used in Plant SCADA to produce a consistent look and feel across all of the pages included in a project. Page levels. The principles of situation awareness propose that your content pages should adhere to a hierarchy that provides different levels of detail about the processes being monitored. This allows an operator to assess a specific process while maintaining a broad view of the overall status of a plant. Here is a description of the various levels. So level 1 is our area-wide overview. Level 2 is our operational overview. Level 3 is the detailed operational processes. And level 4 consists of the auxiliary information. Ideally, a client workstation should have multiple screens with different page levels displayed on each screen. This allows a broader perspective to be maintained while operational details are investigated on lower level pages.
I will now demonstrate the workspace concept in Plant SCADA runtime. From Plant SCADA Studio, we start the project runtime. We do this by clicking the Run Active Project activity. We are then presented with the project homepage displayed in the default workspace layout. At the top, we have the header bar consisting of the home button, the back button. We have the trend analysis where you can view your trends. We've got the active alarms where you can view your currently active alarms. Next, we have the historical events. We also have the shelved alarms, hardware alarms, and we have the top 5 active alarms. On the right-hand side, we can see the user that's currently logged in. We also have the option to log in or log out the current user. Next, we have the options button as well as the help button. On the far right, we have the shutdown button, which is used to shut down the runtime. At the center, we have the page content area that displays pages that have been created using the page content template. We navigate using the navigation zone in the bottom bottom left of the workspace layout and click on production, which then displays the lower level areas under production, and we're going to click on Mixer 100. The Mixer 100 page now displays in the page content area. Within the Mixer 100 page, we're going to click on Pump 1 equipment. By clicking on Pump 1, we can see the Pump 1 has a faceplate that's linked to it. In the faceplate zone at the bottom in the center, we can see the pump faceplate is now displaying information related to the pump, such as start, stop. Okay, we also have some simulation functions to simulate a vibrator fault, a level fault, and a temp fault. As an example, I can interact with the pump from the faceplate. I'm going to start the pump. We can see that the pump is now running. We've got running contact feedback. Okay, and I can stop the pump. Okay, next we're going to click on the level meter, which also has a faceplate linked to it. So I'm going to click on the mixer level. At the bottom in the faceplate zone, we can see that the level meter faceplate is now displaying information related to the level meter. Okay, this information consists of alarm limits, alarm set points, alarm variables, as well as process variables and set points. On the right-hand side in the information zone, if we click on the alarm button, we can see the alarms that's related to the level meter. Okay, by clicking on the trend button, this displays the trend for the level meter. Okay, you have the option of interacting. You can set the time range, or you can stop and start the real time, or you can even select a time range. The interlock button will display interlock information for any currently active interlocks, either safety, process, or permissive.
Data import and export. Most of the plant SCADA configuration data is stored in DBF files. DBF files are database files originally developed to be used by the data management software called DBS6. In general, the Plant SCADA Studio data represented in the grid editor are stored in its own DBF files. These DBF files are found in the project directory and can be manipulated external to the Plant SCADA Studio. In order to use the DBF files, please ensure to add in the Project DBF add-in to your Excel. DBF files are database files originally developed to be used by data management software called DBS6. Most of the Plant SCADA configuration data is stored in DBF files. There are about 96 DBF files, including language DBFs. These are used for multilingual projects in Plant SCADA. In general, wherever you find data represented in Plant SCADA Studio in a grid editor, that data is being stored in its own DBF file. These DBF files are found in the project directory and can be manipulated external to the Plant SCADA Studio. Take care when working on DBF files, as it is easy to overwrite your data with outdated data or inappropriate values. Also, there is a possibility of corrupting the files. It's strongly recommended to back up your DBF files before working on them. AVEVA Industrial Graphics. AVEVA Industrial Graphics is a thin client solution for the delivery of HTML5 graphics and functional content to desktop and mobile browsers. Content is created using the Plant SCADA Industrial Graphics editor. AVEVA Industrial Graphics is a thin client solution for the delivery of HTML5 graphics to desktop browsers and mobile devices. It provides a common graphics technology that can be used across AVEVA's SCADA and HMI solutions, including Plant SCADA, System Platform, InTouch for System Platform, InTouch HMI, Operations Management Interface, AVEVA Edge, and more. Industrial Graphics offers the following benefits: HTML5 visualization that can work across desktop and on mobile with the Android or iOS app. You only need to learn one tool and technology to create the visualization from edge to desktop to cloud. Graphics can be shared with minimal modification to work on any product utilizing industrial graphics. Plant SCADA supports two types of industrial graphics. The first being pages, which is used to host a set of symbols, and symbols, these are industrial graphic objects that are stored within libraries. Plant SCADA uses two types of licensing models: perpetual licensing and flex licensing. Perpetual licenses are permanent and fixed to a specific version with no expiration date and is purchased once off. Additional server, workstation, control client, view client, and Plant SCADA Access Anywhere licenses may also be purchased separately as add-ons as required. AVEVA Flex is a subscription commercial model. Through an AVEVA Flex subscription, customers can purchase AVEVA solutions, manage licenses, and monitor usage. AVEVA Flex uses credits as its program currency. When a customer signs up on a AVEVA Flex subscription, they receive a pool of credits that can be used to purchase a mix of solutions from AVEVA's portfolio. By utilizing the AVEVA Flex licensing model, this enables the option for AVEVA Operations Control solution, whereby a specific number of users are licensed, and this unlocks unlimited installations, unlimited drivers, and unlimited tags. Let's take a look at the latest features for the Plant SCADA 2023 R2. The biggest new feature for Plant SCADA 2023 R2 is a brand new alarm type now configurable in the product, which is termed the double point status alarm. This new alarm type is based upon the existing multi-digital alarm type. However, instead of multiple digital alarm states received by the field device, this one is configured upon a single integer tag, which provides up to 8 states that can be defined with custom naming conventions. Also, these custom state names will be reflected in the alarm and event subsystem so that it can be displayed to show up on all alarm pages. The sequence of events listings, as well as the process analyst tool, which is trend client, that can also display alarm content. It is limited to the driver runtime interface-based protocols, of which we'll cover in more details in the upcoming slides. A double point status alarm is an alarm type that can respond up to 8 states in a field device that are represented in Plant SCADA as a single integer tag. For each state, you can specify the following properties of state name, which is the name that identifies the condition that the state represents, and state type, which is the action that occurs when the device transitions to the defined state. The state type options are selected via the drop-down for the properties field for this alarm type, which will help to determine the behavior of how we want these alarms to appear in our system. Let's take a look at the Plant SCADA runtime and how this new feature works by opening up the example project that is provided with this release. We'll navigate to the new double point status alarms page, where we can use this page to learn more about this new feature. We can use the controls to the left to see how the alarms respond in the system with the various alarm state types identified. As we trigger the alarm for open and closed, it has the state type of event set, so it will only log the alarm into the sequence of events listing at the bottom of the page. Now let's trigger the unknown and jammed alarms, which has the state type of alarm set. Here we can see that the alarms show up as identified and are now displayed in the alarm banner at the top. The active alarms listing, as well as the logging of the alarms properly into the sequence of events table at the bottom. Plant SCADA 2023 R2 provides a new installation experience based upon a brand new installer technology. This install toolkit is modern to the times, as it provides a simple-to-use installation experience with the click-through navigation for component-level installation and modifications, as well as a brand new silent install capability which provides for unattended installations across remaining nodes in the system. This new modern installation framework simplifies the selection and installation of required components. It is built using AVEVA's common technology stack for a similar installation experience, leveraging the AVEVA Install Toolkit, which is used across the entire portfolio. The core Plant SCADA components will appear as a single entry within the program and features list in the Windows control panel, making it much easier to modify, repair, or remove the application. Also, a brand new feature for the product is the fact that the install can be executed via command line, enabling support for unattended silent installation. There are 4 pre-configured response files provided out of the box, which will help you to install all the components. And these components are, all components can be installed a development workstation component, a runtime-only component, as well as components for a runtime-only server. These pre-configured response files can be customized to any of the features needed for the installation, as well as the options to automatically configure items in the configurator, which typically occurs post-installation. Now let's take a look at this new installation feature and how this now works within Plant SCADA 2023 R2. The product is now installed and we are ready to begin developing our Plant SCADA 2023 R2 project. The kernel now works when running as a service. This means that users can now open the kernel for access via the runtime manager and will be prompted for credentials. The legacy Plant SCADA kernel user has been deprecated and a new kernel access property has been added to the role definition, which now controls access. This improves security for kernel access, which is typically used for diagnostic purposes, is now accessible via the Plant SCADA runtime manager. As you click on the various processes running in the system, it will display an option to select the kernel for access. Then a new login prompt screen will appear, allowing you to put in the credentials. This change now takes place by restricting kernel access to the various security roles configured in the system. Each security role now contains a drop-down selection for full access, read-only access, or no access into the kernel. This also means that the legacy kernel user has been deprecated and will need to be migrated during an upgrade process. Unique equipment IDs. A unique ID can be applied to any equipment and equipment types, which can be used for consistent identification or integration with future software releases. Unique IDs for equipment are typically referred to as the Global Unique Identifier or GUID, and they will be used for consistent identification as we integrate this further into the product for a future software release. The global unique identifiers are automatically generated whenever equipment is added, plus the migration tool now includes an option to create these unique IDs for variable tags and equipment during the upgrade process. These future use cases would provide for integration with version control software or tighter integration with AVEVA Historian, as you could now change the name fields in the SCADA system, while auto-binding the new names to the GUIDs stored in the Historian. Equipment update speeds. This feature enhancement to the equipment editor provides tag and equipment generation and update speed improvements, which showed immense speed improvements over previous releases. The performance of equipment update speeds is quite significant, as the time it now takes to generate tags and equipment is faster in this release. Equipment editor is an integral part of Plant SCADA project development within the Plant SCADA Studio. When it is used with large applications comprised of 12,000 pieces of equipment and 50,000 tags, it would previously take 3 hours to configure into the database. But in Plant SCADA 2023 R2, this now only takes 7 minutes. In smaller applications that comprise of 1,000 pieces of equipment and around 9,000 tags, this would previously take 6 minutes to configure into the database, but now only takes less than a minute in this new release. The new online help system is a browser-based tool that means documentation for Plant SCADA is ready for distribution on emerging documentation platforms, including cloud-based environments. Plant SCADA is now aligning towards the AVEVA help standard, which is browser-based, that allows any installed AVEVA product to share a common platform for the delivery of product information. Online version of Plant SCADA will be the most up-to-date revision of the help file located at docs.aveva.com in alignment with the rest of the portfolio. Of course, it is still accessible local to the Plant SCADA 2023 R2 installation from the Windows Start menu, along with any other AVEVA products installed locally. Support for 64-bit Microsoft Excel. The Project DBF add-on tool has been updated to support 64-bit version of Microsoft Excel. The Project DBF add-on utility has been around for many years, but it now fully supports Microsoft Excel 64-bit, which means this add-on tool will now show up as a toolbar within Excel, which allows you to select the Plant SCADA project you're configuring and select the appropriate table for configuration, such as equipment, tags, alarms, trends, or just about any configuration file in the application. Then as modifications are completed, you can save the changes which are directly applied in your Plant SCADA project. AVEVA continually enhances the cybersecurity posture of the product in every release, and captured as a feature due to the significant development which occurred within this area to make the product much more secure for these critical operations. With intuitive configuration tools and powerful engineering features, AVEVA Plant SCADA helps consolidate and streamline control from an increasing array of data sources. This enables the creation of a visually informative supervisory application that maintains operator focus, reducing human error, and revealing opportunities for performance improvement. Plant SCADA's robust capabilities allow a holistic view of operations, empowering teams to not only optimize the now, but also look to the future in the design and acceleration of operations control. Seamlessly weave visualization, alarming, trends, interlocks, and control together for superior operational context. Through improved supervisory control and more effective integration and mobility capabilities, organizations can harness process data to increase productivity and support digital transformations. That wraps up this webinar episode exploring AVEVA Plant SCADA. If you want to hear more about AVEVA Plant SCADA or any other product from our extensive portfolio, be sure to contact us. Hopefully you found this webinar to be insightful. Should you require any further information related to AVEVA Plant SCADA or any other software package from AVEVA's extensive portfolio, please hop onto our website and reach out to us on any of the preferred contact methods.